Based on the properties that we had discussed in the earlier classes, let us start the exercise 7b. So, exercise 7b. First problem, first row one. Integral 0 to a square x minus x cube dx. Let x is equals to a sin theta I take. Then dx is equals to a sin theta derivative is cos theta d theta. So whenever we opt for substitution, we are trying to change the variable of integration x in terms of theta. Therefore, we need to change the limits of the original function as well. We need to find the limits for theta as well. So upper limit a sin theta is equals to a. In the place of x upper limit a, you substitute a gets cancelled. Sin theta is equals to 1. When sin theta is equals to 1, theta is equals to pi by 2 because sin 90 is pi by 2. And lower limit a sin theta is equals to 0. From this, sin theta equals to 0 by a, sin theta equals to 0, then theta equals to 0 degrees. Now, 0 to a square x minus x cube dx is equals to 0 to pi by 2, a square x is a sin theta minus x cube is a cube sin cube theta, dx value is a cos theta d theta. This is equals to 0 to pi by 2, a square into a cube. So here also a cube is there. Take a cube as a common. Then sin theta here is there and here also. So take sin theta also as a common factor. Then we are left with 1 minus. So sin square theta into a cos theta d theta. So a cube into a power 4. So since this is the constant, we are separating from the process of integration. So 1 minus sin square theta is cos square theta. Cos square theta into cos theta. So cos cube theta into sin theta d theta. So here I will take, so here 0 to pi by 2. So here I'll go for substitution again. Let cos theta is equals to, yes, since t is already, cos theta is equals to, otherwise t you take, cos theta is equals to t minus sin theta d theta is equals to dt. Now change the, because this is the function in terms of theta. This theta we are trying it to change in terms of t. Therefore, we need to freshly evaluate the limits for the fresh variable of integration t. So upper limit t is equals to cos pi by 2. Cos pi by 2, cos 90 is 0. And lower limit is t is equals to cos theta. Theta is 0. Cos 0 value is 1. This is equals to a power 4. 0 to pi by 2 has been changed to 1 to 0. So cos cube theta, cos theta is t, cos cube theta is t cube. Sin theta d theta minus sin theta d theta is dt. Multiply with minus on both the sides, then minus of minus plus, this is minus dt. So sin theta d theta is minus dt. A power 4. So this is minus dt. So if we want to remove this minus, we need to interchange the limits. So this is 0 to 1 t cube dt, since they have the property that integral a to b f of x dx is equals to integral minus integral b to a f of x dx. So using this property, this minus I have taken off. Since this is 1 to 0, 0 to 1 I have written. A power 4 integral t cube dt is t power 3 plus 1 by 3 plus 1. So since the process of integration is over, so here we need to write like this. A power 4, 3 plus 1 is 4 into, so this is t power 4. In the place of t, substitute upper limit 1. So 1 power 4 minus, this is in the place of lower limit, in the place of t, substitute a lower limit. So 0 power 3 plus 1, so 4. So 1 power 4 is 1 minus 0 is totally, this is 1 into this, a power 4 by 4. So the next question is integral 2 to 3 2x by 1 plus x square dx. Clearly this is 1 plus x square. If I take, let 1 plus x square equals to t, then whenever we are taking the substitution, we are going for substitution, immediately the next step we need to do is to differentiate. So 2x dx is equals to dt. So now what we need to do later, because since this is the function in terms of x, the integrand is in terms of x, therefore x is the variable of integration, and for that variable of integration 2 to 3 are the limits, but that variable of integration x we are trying to change in terms of the next variable of integration, which is t. So we need to evaluate the limits for t. So upper limit t is equals to 1 plus x value is 3. So 3 square, so which is 10. Lower limit t is equals to 1 plus 2 square. 2 square 4 plus 1 5. Therefore integral 2 to 3 2x by 1 plus x square dx is equals to 2 to 3 has been changed to 5 to 10. 2x dx is dt by 1 plus x square is t. So what is this is of the form 5 to 10 1 by t dt. So this t is the dummy variable, because definite integral is nothing to do with the variable. So there is no difference if it is integral 1 by x dx. So therefore if we assume it as integral 1 by x dx log x, so log mod x, here log mod t. So as the process of integration is over, so 5 to 10 we need to write here. So log upper limit, in the place of t substitute upper limit, minus log in the place of t substitute the lower limit. Log a minus log b, log a by b. So log 2 is the answer. Next, so we don't need to do these many steps. So we have the results. What are the results? Integral f dash x by f of x dx log modulus of x plus constant of integration c. Integral f dash x by root f of x dx 2 root f of x plus c. Integral f of x whole power n into f dash x dx f of x whole power n plus 1 by n plus 1 plus c. Next, integral f of f dash x into root f of x dx. This is nothing but the application of this. So whole power n, this is f of x whole power 1 by 2. In the place of n, 1 by 2. So this is 2 by 3 f of x whole power 3 by 2 plus c. So these are the results. Directly we can deal this problem using the result also. Because see, this 1 plus x square is treated to be f of x. What is the derivative of this? 1 derivative is 0, x square derivative is 2x. So it is f dash x by f of x. What is integral f dash x by f of x? It is log mod f of x. So I'll enter integral f dash x by f of x is, here I'm writing, so 2x by 1 plus x square dx. So 1 plus x square is f of x, its derivative is f dash x here. So f dash x by f of x dx, log f of x. So log f of x. So what is f of x here? 1 plus x square. Since the process of integration is over, because logarithm is always a positive, therefore we are generally keeping it in modulus. So 2 to 3. So log 1 plus 3 square, so log 10, minus log 1 plus 2 square, 5. Still the same, log a minus log b, log a by b, log 10 by 5, log 2. So you can check with the earlier answer also. Now, the third question, integral 0 to pi root of 2 plus cos theta d theta. This is equals to 0 to pi square root of, take 2 as a common factor, so 1 plus cos theta d theta. So 0 to pi, so square root of 2 into, what is 1 plus cos theta? What is 1 plus cos 2 theta? 2 cos square theta. 1 plus cos 2 theta value is 2 cos square theta. 1 minus cos 2 theta value is 2 sin square theta. So if it is 2 times, here it will be half of that. 2 theta by 2 is theta. Similarly, what is 1 plus cos theta then? 2 cos square theta by 2. Similarly, 1 minus cos 2 theta, 1 minus cos theta is 2 sin square theta by 2. So using this trigonometric identity, what is 1 plus cos theta here? 2 cos square theta by 2 d theta. So 0 to pi, so 2 2s are 4 under root 4 is 2. So I have separated this 2 from the process of integration. So cos square theta by 2 square root gets cancelled. I left with cos theta by 2 d theta. So 2 into, we know integral cos x dx. What is integral cos x dx? Sin x plus c. What is integral cos theta by 2? So this is sin theta by 2 by theta quotient is 1 by 2. That we need to divide. So that is 1 by 2. As the process of integration is over, so as usually we need to apply this 0 to pi here. So 1 by 2 is 2. 2 2s are 4 sin upper limit, in the place of theta substitute upper limit pi by 2 minus sin, in the place of theta substitute lower limit 0 by 2 0. So 4 sin 90 value is 1 minus 0. So 4 ones are 4. So the next question is integral 0 to pi sin cube x into cos cube x dx. So how do we do this? We have integral 0 to 2a f of x dx is equals to 2 integral 0 to a f of x dx if f of 2a minus x equals to f of x. Likewise, the same value is 0 if f of upper limit minus x is equals to minus f of x. This we have discussed in the properties. Similarly, 0 to a f of x dx is equals to 2 integral, had it been 2a, so 2 will come forward and this upper limit 2a by 2a we will. So in the same way 0 to a, 2 will naturally come forward and half of this upper limit is 0 to a by 2 f of x dx if f of upper limit minus x equals to f of x. The same value is 0 if f of a minus x equals to minus f of x. So for this solution, let f of x is equals to the given function sin cube x into cos cube x. So 0 to pi, in the place of pi, a is there. Therefore, this can be compared with this property. So let us take f of x is equals to this. So to apply in this property, what do we need to check? F of a minus x, upper limit minus x. Here upper limit is pi. So let us check upper limit pi minus x. So sin cube x is pi minus x, cos cube x is pi minus x. So what is sin 180 minus x? Second quadrant. Sin 180 minus x is sin x only, whole cube, sin cube x into what is cos 180 minus x? Minus cos x whole cube. So minus cos x whole cube is minus cos cube x. So this is minus sin cube x into cos cube x. So same value we got, same sin cube x into cos cube x, same value we got with a minus sign. So since therefore f of pi minus x value is minus f of x, that means f of a minus x is minus f of x, then this value is 0. Therefore this value means this value equals to how much? Therefore 0 to pi sin cube x into cos cube x dx is equals to 0. So the next question is integral 0 to 2 modulus of 1 minus x dx. So we don't know between which interval this modulus function is positive and between what interval this is negative, because modulus of x has a property what? Modulus of x equals to x if x greater than 0. So is equals to 0 if x is equals to 0, is equals to minus x if x less than 0. So because modulus of x is equals to plus or minus x, so plus x at x greater than 0 minus x at x less than 0. So similarly the behavior of this 1 minus x under modulus is also we don't know. So we need to find another value in between 0 to 2. How do we get? Simply 1 minus x equals to 0, then x equals to 1. So 1 minus x equals to 0 implies x equals to 1. So between 0 to 2, 1 is there. Therefore, this need to be splitted from 0 to 1 and 1 to 2. We have the property that C is lying in between A and B. Then integral A to B f of x dx is equals to A to C f of x dx plus C to B f of x dx. So we have discussed this in the fourth or fifth property. that we have discussed before. So similarly, let us examine 0 to 1 solution. 1 minus x is equals to 1 minus x positive if x is less than 1, because so x less than 1, 0 to 1 interval you take. So between this you take any value which is in between. For example, 0.5 you take and substitute. So 1 minus 0.5, so 0.5. So 0.5 is what? It's positive. So if x less than 1, this value is positive. The same value is negative if x greater than 1. How? So greater than 1 means between it lies in the interval 1 to 2, right? So 1.5 or 1.6, whatever you take. So for example, for convenience, 1.5 you take and substitute that value in this. So 1 minus 1.5 minus 0.5. So minus means a negative. So if x is greater than 1, this value is a negative. Therefore, integral 0 to 2 modulus of 1 minus x dx equals to integral modulus of 1 minus x dx plus integral 1 to 2 modulus of 1 minus x dx. This implies 0 to 1. 0 to 1 means less than 1, right? So this value is 1 minus x dx plus 1 to 2 means more than 1, greater than 1. This value is minus of 1 minus x. That means 1 to 2 minus of 1 minus x dx. This is equals to 0 to 1, 1 minus x dx. So plus into minus. So this is minus into minus plus, minus into minus plus, minus into 1, minus 1. So this is x minus 1 dx from 1 to 2. Okay. Now integral 1 dx is x minus integral x dx is x square by 2. Since the process of integration is over, we need to apply the limits here. Plus integral x dx is x square by 2 minus integral 1 dx is x. So 1 to 2 limits are to be written here. So substitute the upper limit minus lower limit wherever you find x. So here I could find x here. In the place of x, upper limit 1 minus lower limit 0 minus 1 by 2 if you take aside, then in the place of x upper limit 1 you substitute 1 square minus in the same x square substitute lower limit, so 0 square plus here 1 by 2 you take it aside, in the place of x square substitute upper limit 2 square minus in the place of x substitute lower limit 1 square minus of in the place of x substitute upper limit minus in the place of same x substitute lower limit which is 1. So the remaining problem I will write here. So 1 minus 0 is 1. So 1 square is 1. 1 this is how much? 1 by 2 plus 2 square 4, 4 minus 1 3, 3 into 1 by 2 3 by 2 minus 2 minus 1 is 1. So this is 1 minus half plus 3 by 2 minus 1. 1 gets cancelled. So 3 by 2 minus 1 by 2, 3 minus 1 by 2, 2 by 2 which is 1. The next problem, integral minus pi by 2 to pi by 2 cos x by 1 plus e power x dx. So this is seemed to be of the property minus a to a f of x dx. This is equals to 2 integral 0 to a f of x dx if f of minus x is equals to f of x. The same value is equals to 0 if f of minus x equals to minus f of x. F of minus x equals to f of x means f of x is an even function. And if f of minus x equals to minus f of x is a odd function. Let us examine. So let f of x is equals to cos x by 1 plus e power x x. So f of minus x is cos minus x by 1 plus e power minus x. Of course, cos minus x is cos x because cos x is the even function by 1 plus e power minus x. But here we did not get minus f of x because it is some other function, because we are not sure about e power minus x. Okay? Because this whole function cannot be written as f of x. F of minus x is not equals to f of x. Since this doesn't follow this actual process, therefore we need to go for another method. So we have another property. Integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. So using this property, minus pi by 2 to pi by 2 cos x by 1 plus e power x dx is equals to minus pi by 2 to pi by 2. So because a to b we are going to get again. Therefore, it won't be changed. Minus pi by 2 remains same. So here in the place of x, upper limit plus lower limit minus x. Upper limit plus lower limit minus x. That's why in this integrand, wherever you find the value of x, substitute upper limit plus lower limit minus x. So cos pi by 2 plus into minus minus pi by 2 minus x by 1 plus e power, in the place of x, upper limit plus lower limit minus x. So pi by 2 minus pi by 2 minus x dx. So pi by 2 gets cancelled, pi by 2 gets cancelled. So minus pi by 2 to pi by 2 cos minus x is cos x by 1 plus e power minus x is 1 by e power x dx we can write. So minus pi by 2 to pi by 2. So cos x by, this is e power x into 1, e power x plus 1 by e power x, LCM. So e power x plus 1. So this e power x will go onto the numerator into e power x dx. So minus pi by 2 to pi by 2. So e power x cos x by e power x plus 1 dx. So the original function is 1 and this is 2, let us suppose. This is also I only. So this is, let I is equals to is what I am taking. So integral a to b f of x dx equals to integral a to b f of a plus b minus x dx. Therefore, this value is also I. So now 1 plus 2 gives rise to I plus I. 2i is equals to For both of them, minus pi by 2 to pi by 2 are the limits. For both of them, 1 plus e power x plus 1. LCM is same, 1 plus e power x. So cos x plus e power x cos x. Cos x plus e power x cos x. So in this way, I have added both of them, this as well as this. So implies 2i is equals to minus pi by 2 to pi by 2. Take cos x as a common. So e power x plus 1 by 1 plus e power x dx. This gets cancelled. So 2i is equals to, so minus pi by 2 to pi by 2 cos x dx. Now listen, this is of the form minus a to a f of x dx. In the beginning I have written minus a to a f of x dx. It will be 2 integral 0 to pi by 2 cos x dx. Can I write? If f of minus x equals to minus f of x, since I have written it to be minus a to a f of x dx equals to 2 integral 0 to a f of x dx. If f of minus x equals to f of x, here this you take as f of x. So let f of x is equals to cos x. F of minus x equals to what? Cos minus x. So cos minus x is what? Cos x. That implies 2i is equals to, so therefore, since f of minus x equals to f cos x, which is f of x, therefore minus a to a f of x dx equals to 2 integral 0 to a f of x dx we can write, because this is the explanation for that. So 2i is equals to 2 integral 0 to pi by 2 cos x dx. So this two gets cancelled, implies I is equals to, what is integral cos x? Sin x. So since the process of integration is over, 0 to pi by 2 is to be written here. Sin in the place of x upper limit pi by 2 minus sin in the place of x lower limit is 0. Sin 90 value 1 minus 0, which is 1. Therefore, I is equals to 1. What is I? The given question. Integral 0 to 1 dx by square root of 3 minus 2x. What is integral 1 by root x dx? This is 2 root of x. X is 3 minus 2x. Since we have treated this to be x, then it has become integral 1 by root x dx. So by whatever that we have treated earlier to be x, we need to differentiate it. So what is the d by dx of 3 minus 2x? 3 is 0, minus 2x is minus 2. Why we are dividing? Because in differentiation, whatever that we have taken it to be x into d by dx of that we used to do in the first year. Since this is the integration, instead of into d by dx of something, so we need to divide it by that d by dx of what we have taken earlier to be x. That is why here d by dx of 3 minus 2x, so which is minus 2. So 2 gets cancelled. So since the process of integration is over, 0 to 1 is to be written here. So minus square root of, in this function apply the upper limit. So 3 minus 2 ones are 2 minus, in the place of this x, substitute up a lower limit. 3 minus 2 into 0, so 3 minus 0. So this is equals to 3 minus 2 is 1 under root, so 1 minus root 3. So minus into minus plus, so root 3 minus 1. is integral 0 to a root a minus root x whole square dx. So integral 0 to a, so a minus b whole square, a square plus b square minus 2ab. Root a whole square is a plus root x whole square is x minus 2 root of ax dx. Now integral a dx is ax plus integral x dx is x square by 2 minus 2 root a is the constant. You separate it from the process of integration. Integral root x dx is 2 by 3 x power 3 by 2. Since the process of integration is over, so simply we need to apply. We need to write here the upper limit as well as lower limit. So you can substitute this upper limit as a whole once minus lower limit 0 for all this. Otherwise individually also you can substitute the upper limit minus lower limit wherever you find x. So here I could see x in the place of x, upper limit minus lower limit plus 1 by 2 into in the place of x upper limit a square minus in the place of the same x lower limit 0, square is already there, minus 2 2s are 4 by 3 into root a into in the place of x upper limit a power 3 by 2 minus in the place of x lower limit 0 power 3 by 2. This is a square by 2 minus 4 by 3 root a. So root a can be written as a power 1 by 2 also into. So this is a square plus a square by 2 minus 4 by 3. This is a power 1 by 2, a power 3 by 2, a power 3 by 2 plus 1 by 2, a power 4 by 2, which is a square. So LCM is 2 3s are 6. So 6 by 1, 6 into a square, 6a square. 6 by 2, 3 into a square, 3a square. Minus 6 by 3, 2 4s are 8a square. So this is 6 plus 3, 9a square minus 8a square. A square by 6. The ninth question, integral 0 to pi by 2 secant power 4 theta d theta. So I want to tell you that this has been misprinted in the textbook. It is not pi by 2, it is pi by 4 instead. Now 0 to pi by 4, secant power 4 theta is secant square theta into secant square theta d theta. Can we write? Integral 0 to pi by 4, since secant square theta minus tan square theta is equals to 1, secant square theta is 1 plus tan square theta into secant square theta d theta. So this is 0 to pi by 4. 1 into secant square theta is secant square theta d theta plus 0 to pi by 4 tan square theta into secant square theta. Now integral secant square theta d theta is tan theta. Since the process of integration is over, we have to write 0 to pi by 4 here, and here integral tan square theta secant square theta. So if I take tan theta as t, then tan theta whole square into tan theta derivative is secant square theta. It is of the form f of x whole power n into f dash x dx. F of x whole power n plus 1 by n plus 1 plus c. That means here f of x is tan theta, n is 2. So n plus 1 by n plus 1 means tan cube theta by 3. Process of integration is over. 0 to pi by 4 has to be written here. So tan theta value is tan pi by 4 minus tan 0 plus 1 by 3 into tan cube pi by 4 minus tan cube 0. So tan 45 is 1 minus 0 minus plus 1 by 3 into tan 45 value is 1 minus 0. So 1 plus 1 by 3. 3 ones are 3 plus 1, 4 by 3. So the next question is integral 0 to 3 x by square root of x square plus 16 dx. So x square plus 16's derivative is x square derivative is 2x. So here x is there, for which we need to have some adjustment. We need to balance. So since I require 2x here, 2 I multiply, equally I divide also without loss of generality. 0 to 3 by square root of x square plus 16 dx. So x square plus 16 is f of x. Its derivative is situated on the numerator. It is integral f dash x by root f of x dx is 2 root of f of x plus c. So here 1 by 2 into f dash x by root f of x, 2 root of f of x, 2 root x square plus 16. Since the process of integration is over, so we need to write the limiting values here. So 2 gets cancelled. So square root of, in the place of this, in the place of x, substitute upper limit. So 3 square plus 16 minus square root of, in the place of x, apply substitute lower limit. So 0 square plus 16. So 3 square 9 plus 16 root 25 value 5 minus root 16 value 4. 5 minus 4 is 1. The next question is integral 0 to 1 x into e power minus x square dx. So we can go for the substitution because see here x square is there and x is there. If we take x square as the function t, then its derivative is 2x. So here x is there. So we need to have an adjustment. So let x square is equals to t. X square derivative is 2x dx is equals to dt. Whenever we are going for the substitution method, so 0 to 1 are the values of the variable of integration x. This x we are trying it to change in terms of t. Therefore, we need to find the values for t as well. Upper limit t is equals to x square. So 1 square. This is equals to 1. Lower limit t is equals to 0 square. Lower limit is 0. So this is 0. So this will become 0 to 1 is still 0 to 1 only. So e power minus x square is t. X dx is 2x dx is dt. X dx is dt by 2. So this is dt by 2. So 1 by 2 I am separating from the process of integration. So 0 to 1 e power minus t dt. So 1 by 2. So let us suppose this to be x. Integral e power x dx is e power x. So e power minus t into, since it is taken it to be x, by we need to divide it with the d by dt of minus t. So which is minus 1. Since the process of integration is over, we need to write the value 0, 1 here. So 1 by 2 into minus 1 is minus 1 by 2 e power minus, in the place of t upper limit 1 minus e power in the place of t, lower limit 0. So minus 0. So minus 1 by 2, e power minus 1 value is 1 by e. E power minus 0 means e power 0 value is 1. So minus 1 by 2, 1 minus e by e LCM. So e minus 1 by 2 into e. The next question is integral 1 to 5 dx by root 2x minus 1. So it is of the form integral 1 by root x. How much? 2 root x. X is 2x minus 1. Since we have taken it to be x, that's why it has become integral 1 by root x by whatever the thing that we have taken it to be x, we need to divide it by its derivative. So d by dx of 2x minus 1, 2x derivative is 2, x derivative 1 minus 1 derivative is 0. So here 1 to 5 is to be written here, 2 gets cancelled. So square root of 2 5s are 10 minus 1 9 minus square root of 2 1s are 2 minus 1 1. So root 9 value 3 minus 1 which is 2.